On the morning of May 30th, 1832, a passing peasant found a 20-year-old face down by a pond near Paris, shot through the stomach. He died the next day. He was 20 years and 4 months old. In his pockets were the seeds of a theory 2 centuries of mathematicians, physicists, and cryptographers would build on. And almost everything later told about that night is fiction. How does a boy who failed his entrance exam twice invent the language of symmetry? Begin in Bourg-la-Reine, a small town 6 miles south of Paris, October 1811. Napoleon is still in power. His father, Nicolas Gabriel, runs a small boarding school and composes rhymed couplets to delight neighbors at house parties. It is a gentle talent. One day it will kill him. His mother, Adelaide Marie, is fluent in Latin, openly skeptical of religion, and his sole teacher for the first 12 years of his life. In 1815, Napoleon's 100 days, Nicolas Gabriel becomes mayor. He keeps the post when the Bourbons return. A liberal mayor in a town tilting reactionary. The local priest will not forget. Outside Bourg-la-Reine, the Bourbons are back. The Jesuits are back. The revolution still smolders. In October 1823, the family rides into Paris. They drop 12-year-old Évariste at the gates of Lycée Louis le Grand. Louis le Grand, a 250-year-old boarding school in the Latin Quarter. Cold stone, locked gates, 600 boys. The new provisor is suspected of bringing back the Jesuits. Students refuse to sing in chapel, refuse to toast the king. 40 boys are summarily expelled. Galois is not among them. He watches. He is 12. The arbitrariness of authority imprints on him. His teacher reports drift. Year 1, work sustained, conduct good. By year 2, character closed, original. At 15, he is held back a year in rhetoric for poor work, a punishment, an accidental gift. Because the punishment puts him, in February 1827, in Monsieur Vernier's first mathematics class. He picks up Legendre's geometry. He reads it like a novel, cover to cover, in 2 days. Then Lagrange's memoirs, same way, as if they were stories. Let me show you what Galois saw. Start where everyone starts, the quadratic. ax squared plus bx plus c. Its roots can be written down. Minus b plus or minus root delta over 2a. A formula in the coefficients with a square root. That's what mathematicians mean by solvable by radicals. You can write the roots. In 1545, an Italian named Cardano cracked the cubic. The formula is hideous, but it exists. That same year, Cardano student Ferrari cracked the quartic, degree 4, done. And then the quintic. For 250 years, Europe's best mathematicians tried. Lagrange, Euler, Vandermonde, all came back empty-handed. In 1770, Lagrange writes a long, thoughtful paper. Tucked at the back, in note 13, he studies how the roots permute. How they swap, how they rearrange. He suspects the answer lives there. In 1799, an Italian named Ruffini writes hundreds of pages claiming the quintic is impossible. His proof has a hole. In 1824, a 21-year-old Norwegian named Niels Abel finally proves it cleanly. No quintic formula exists. He prints it himself on 6 pages. And in February 1828, in Paris, a 16-year-old named Galois picks up Lagrange's note 13. He reads it in 2 days. Abel had proved no formula exists. Galois will explain why. April 1829. Galois is 17. He publishes his first paper on continued fractions. A month later, he submits his first researches on equations to the French Academy. The referee is Augustin Louis Cauchy. Now, for 100 years, the legend was that Cauchy lost the papers, threw them away, crushed an inconvenient genius. That story comes mostly from one man, E.T. Bell, in 1937. In 1971, the historian René Taton found a letter Cauchy had written to the Academy on January 18, 1830. 6 months after receiving Galois' manuscript, Cauchy still had it. He had read it. He planned to present it that very day. He was, in his own words, indisposed at home. He did not lose the papers. He almost certainly encouraged Galois to consolidate them for the Academy's grand prize. And then, on July 2, 1829, disaster. The local priest in Bourg-la-Reine has been forging scurrilous epigrams in the mayor's name. They circulate. Nicolas Gabriel is humiliated. He flees to Paris. In a small apartment 2 steps from Louis le Grand, he asphyxiates himself. Évariste is 17. At the funeral, the same priest tries to officiate. A small riot breaks out. Stones are thrown. Days later, Galois sits the École Polytechnique entrance exam. His second attempt. His last. Legend says he hurled an eraser at the examiner. The historian Dupuy says, only tradition. What we know is, he failed. He enrolls instead at the lesser École Normale. His father's coffin is barely cold. In February 1830, he submits a grand prize entry to Joseph Fourier. Fourier dies in April. The manuscript is never recovered. The prize goes to Abel, posthumously, and Jacobi. By 18, Galois has lost his father, his prize, and his school of choice. Now, let me show you what Galois actually saw. Pause here. We start small. X squared minus 5x plus 6. It factors. The roots are 2 and 3. What if I write it as x minus 3 times x minus 2? Same polynomial, the labels are interchangeable. The polynomial does not see 2 and 3, it sees 2 roots, swappable. Move up to a cubic, 3 roots, 1, 2, 3, 6 ways to list them, all produce the same polynomial. 6. 3 factorial. The polynomial is invariant under all 6 rearrangements. A permutation is just a way of moving labels around, from this list to that list. In 1844, Cauchy gave it a notation. Top row, where you start. Bottom row, where you end up. Galois, and the paper we're working from, write down all 6 for 3 elements. They called this set S3. S1, a circular substitution. 1 goes to 3, 2 to 1, 3 to 2. S2, the other circle, the reverse direction. T1, T2, T3. 3 transpositions. Each swaps 2 elements, leaves the third alone. Plus the identity, do nothing. 6 elements. That is S3. Now, apply one swap, then another. The result is a third swap, already in the list. You never escape the set. Galois lays it out as a 6x6 table. Rows are first move, columns are second, entries are the result. Closed under composition, has an identity, has inverses, associative. These four properties together, this object, is what mathematicians call a group. In 1934, Évariste distilled it. It is no longer the degree of an equation that measures its difficulty, but the nature of its group. Take the quartic, x to the fourth minus 5x squared plus 6, 4 roots, plus or minus root 2, plus or minus root 3. There are exactly 4 symmetries, and they get names. Call them id, x, y, and z. X swaps the 2 root 2's and leaves the root 3's alone. Y is the mirror. It swaps the root 3's. Z does both at once, and id, of course, does nothing. 4 moves you can compose, chain, and undo. That's all a group really is. Ours is the Klein 4 group. But why exactly those 4 and no others? Look at the equation. It only sees x squared. Flip the sign of root 2. X squared doesn't notice. The equation is unchanged. That's what symmetry means here. Now, Galois' central word, adjoin. To adjoin a number is to agree by fiat that we now know it. And the playground we adjoin numbers TO has a name, a field. A number system where you can freely add, subtract, multiply, and divide. The rationals are 1. The reals are 1. Start with the field of rationals. Adjoin root 3. Now numbers like 2 plus 5 root 3 live inside a new, bigger field. Once we know root 3, y and z are caught. They swap a value we now recognize. They die. Only id and x, which never touched the root 3's, survive. The group has been cut in half, from 4 elements to 2. Now adjoin root 2. X, the last survivor, gets caught too. The group collapses to a single element, id alone. One element means no symmetries left. The roots are pinned down. The equation is solved. Watch this. On one side, fields grow upward as we adjoin radicals. On the other, the group shrinks downward. Each new tool kills one row of symmetry. They are mirror images. Solving an equation by radicals, climbing the field ladder, is unscrewing the group. There is a name for the kind of subgroup you are allowed to mod out by, a subgroup along which the group can be folded cleanly. Galois calls them a normal subgroup. And solving by radicals means the group can be folded all the way down to nothing, one normal subgroup at a time. Now, at last, the quintic, x to the fifth minus x minus 1. Its symmetry group is S5, all permutations of 5 things, 120 elements. S5 has exactly one large normal subgroup. We call it A5, the alternating group of order 60. And a 5 refuses to fold. It has no normal subgroups. Mathematicians call this simple. Not easy, the opposite, atomic, unbreakable. No tower of radicals can ever climb past A5. The group cannot be unscrewed all the way down. Therefore, no quintic formula, not because we haven't found it, because none exists. Abel proved this in 1824. He gave the result. Galois, at 19, gave the reason. July 1830. 3 days of revolution in Paris. Charles X flees the country. At the École Normale, the director, Monsieur Guignol, locks the students in. Galois tries to scale the wall. He fails. He misses the revolution. He never forgives. Louis-Philippe takes the throne. In December, Galois publishes a blistering open letter against Guignot and is expelled. He joins the artillery of the National Guard, the militia branch dominated by Republicans. 2 weeks later, the king dissolves it. They are too dangerous. May 9, 1831. The Vendange de Bourgogne. 200 Republicans celebrating the acquittal of 19 artillery officers. Galois rises with a glass in one hand and an open pocket knife in the other. He toasts the king. To Louis-Philippe, if he betrays. The qualifying clause is drowned in the cheering. Alexandre Dumas, sitting 2 tables away, jumps out the window. Arrest at his mother's house the next morning. June 15th. Trial. The defense reveals the qualifying clause. The jury acquits him in minutes. Bastille Day, July 14th, 1831. Galois walks the streets in the now illegal artillery uniform. He carries a loaded rifle, 2 pistols, and a dagger. Witnesses say, armed to the teeth. He is arrested again. This time, it sticks. Sainte-Pélagie, 6 months. He is 19. Raspail, a fellow prisoner, kept letters. The other inmates taunt the teetotal Galois into drinking. He refuses to look cowardly. He drinks. Glass after glass. The next night, a whole bottle of brandy. Drunk for the first time, he prophesies, verbatim, that he will die in a duel over, quote, some coquette of low rank. Then he attempts to take his own life. His cellmates restrain him. In October, the Academy's verdict arrives, signed by Arago, but the report is Poisson's. It is not, contrary to legend, a flat rejection. The proofs are neither sufficiently clear nor sufficiently developed. Poisson asks for a fuller exposition, by 1831 standards, an encouraging rejection. Galois, in prison, with no advisor, no audience, reads it as betrayal. In December, in his cell, he writes a preface, 5 pages of furious clarity. I shall not encumber this work with surnames or titles. I owe nothing of value to the encouragement of important men. The whole thing was written in prison, hardly suited for meditation. He resolves to publish it himself. He never gets the chance. March 1832. Cholera sweeps Paris. Galois is transferred from prison to a private pension, the Sieur Foltrier. The resident physician has a daughter. Her name was hidden for over a century. In 1968, the historian Carlos Infantozzi sat with Galois' manuscripts under a magnifying glass. He read, beneath erasures, a name Galois had tried to scrub away, Stéphanie Félicie Poterin du Motel. A doctor's daughter, 26 years old, not a prostitute, not an agent provocateur. 2 of her letters survive. Galois copied them onto the back of a math manuscript with the names erased. Both letters ask him, gently, to stop pursuing her. On May 25th, he writes, Chevalier, how can I console myself when in 1 month I have exhausted the greatest source of happiness a man can have? On the evening of May 29th, 2 nights before the duel, he writes Chevalier the long mathematical letter. The legend from Bell says Galois invented group theory that night, in a panic, from scratch. What Galois actually did that night was annotate, margins, cross-references, pointers to results he had refined for 3 years. The famous I have not the time, je n'ai pas le temps, appears exactly once, in a margin. And even there, Galois undercuts his own romance. He adds in parentheses, author's note. His adversary was almost certainly Pêcheur d'Herbanville, not a royalist hitman, not a police agent, a fellow Republican. One of the 19 artillerymen acquitted at the trial. Lafayette personally testified for him. The crowd had pulled his coach through the streets of Paris in applause. May 30, dawn, a pond near the pension. The two men stand 25 paces apart. They fired. Galois fell. The seconds, depending on whose account, abandoned him or went for a doctor. A passing peasant found him an hour later. He was still alive. Hospital Cochin. His brother Alfred sat with him through the night. Galois refused the services of a priest. He died on June 1, 1832. His last recorded words to his brother, "Don't cry, Alfred. I need all my courage to die at 20. The funeral was June 2nd. 2,000 to 3,000 Republicans attended. He was buried in a common grave. No marker survives. The papers go to his brother Alfred and his friend Chevalier. They recopy them. They send them to Gauss, to Jacobi. Neither answers. For 11 years, the manuscripts sit in a drawer. In 1843, Joseph Liouville, professor at the Collège de France, sits down with the bundle. He spends months. He says later that he had to learn how to read Galois. In September, he tells the Academy the boy was right. In 1846, 14 years after the duel, Galois' memoir appears in Liouville's journal. In 1854, Arthur Cayley reads it. He writes the first abstract definition of a group. In 1870, Camille Jordan publishes the Traité des Substitutions, the first systematic exposition of Galois theory. 2 years later, Felix Klein delivers the Erlangen program, declaring that geometry itself is the study of symmetry groups. From a desk drawer in Paris to the foundation of modern geometry. 40 years. In 1918, Emmy Noether proves a single, devastating theorem. Every continuous symmetry of a physical system corresponds to a conservation law. Energy is conserved because the laws of physics are the same yesterday, today, tomorrow. Momentum because they are the same here as there. Charge because of an internal phase symmetry. Every conservation law in physics is a symmetry, a group. The Standard Model, our best theory of matter, is a story about 3 groups, SU3, SU2, U1. And closer to home, every QR code, every CD, every deep space transmission relies on Reed-Solomon error correction. The workhorse of digital storage, built on Galois fields. RSA, elliptic curve cryptography, the encryption protecting your messages tonight, finite groups. In 1995, Andrew Wiles proved Fermat's last theorem using Galois representations of elliptic curves. Every text message you send tonight is encrypted using a Galois field. He never lived to see one. So, was he murdered by the regime? The historical evidence says no. Was he a misunderstood angel? No. He was difficult, paranoid, brave, and right. Sophie Germain, no enemy of his, wrote that he would go completely mad. The myth, Bell's myth, is smaller than the man. What he left behind was not a martyrdom, it was a question, an answer, and a language. That language now runs through algebra, through physics, through every encrypted second of the modern world.